Hello everyone, am I audible? I hope I'm audible. So I start with the reading and explanation of one of the chapters of 10th standard ICSE geography, that's water resources. This is an attempt as per the demand of one of the viewer of this channel who wanted me to read out the chapter, maybe because now the students have really lost their patience out to read, possibly. And this is the reason why I shall keep reading. All those students who are just want to revise it up, okay, just like you hear up a audio book. So this is going to sound more or less like an audio book. So you please listen to me. I'm starting up with chapter number 11, water resources. So we start with sources of water. About 97% of the Earth's water supply is in the ocean, which is unfit for human consumption and other uses due to high salt content. We can't drink the marine water, right? We can't drink the salty sea water. So that is what it means. So it is unfit for human consumption. Of the remaining 3%, 2.3% is locked in the polar ice caps. This can be asked to you in the MCQs. The balance, 0.7%, is available as fresh water, but 0.66% is groundwater, and the rest, 0.03%, is available to us as fresh water in the rivers, lakes, and the streams. You need to remember all these values. Okay, so we start with the first one, that is surface water. Water on the land is the result of precipitation or seepage from underground, which forms streams and rivers flowing on land and finally joining the sea. Second, that is B, groundwater. The water from precipitation, that is from rain or snow, flows on the surface. Some of the water evaporates and the rest sinks into the soil. The water which gets collected under the surface of the land is known as groundwater, which remains in soil, subsoil, or bedrock. Most of the water ultimately reaches the sea. An underground water stream that is saturated with water and transmits water readily is known as an aquifer. Groundwater constitutes 0.66% of usable water on the earth. Nature has endowed India with plentiful water resources. These resources account for 4% of the world's water resources. Besides surface water, that is, from rivers, lakes, ponds, and tanks, and groundwater resources, India has a vast coastline with indented coasts in some states. Odisha, Kerala, and West Bengal have vast surface water resources in the form of lagoons and lakes. Though water is brackish in these water bodies, it is utilized for fishing and irrigation of certain crops like paddy, coconut, etc. Brackish water is nothing but the water wherein the sea water and the river water, that is the fresh water and the salty water, mix. So that is called as the brackish water. Now, why is there a need to conserve water? Water is a natural resource which satisfies the basic human need. Due to increase in population, irrigation, and industrialization, the demand for water has risen. This has led in scarcity of water to such a level that it is being said that the Third World War will be fought over the issue of water. We need to conserve water for the following reasons. Okay, Prem Sahu, hi बच्चा, आप हो यहाँ पर? Do I answer you? Are you there? Please reply. Definitely, I'm happy to take your questions. Okay, so it's not just going to be plain reading. If you have any questions, definitely you can post up the question. So, Prem Sahu, you have asked me what is a lagoon. A lagoon is a shallow body of water जहाँ पर पानी बहुत ज़्यादा नहीं है, बहुत ज़्यादा depth नहीं है. Okay, so that's a shallow body which is separated from a larger body of water by a narrow landform. एक छोटा सा रीफ कहो या बैरियर, एक छोटा सा जमीन का टुकड़ा है जो उन्हें सेपरेट करता है एक लार्ज बॉडी वाटर को एक शैलो बॉडी वाटर से. ठीक है, so such a area is called as a lagoon. So lagoon is a shallow body of water which is separated from a larger body of water by small piece of land. Lagoons are commonly divided into coastal and atoll lagoons. Okay, आपको सिर्फ इतना ही याद रखना है कि lagoon का मतलब क्या है. प्रेम साहू, are you okay? I mean, have I answered you correct? या और भी कोई डाउट है आपको तो प्लीज आप पूछिएगा, not a problem. प्रेम साहू, if you have understood, please reply. Okay, so we go to the next, that is why we need to conserve water for, I mean, which are all the reasons that we need to conserve water. First, the over exploitation, that is excessive use. Okay, excessive use of underground water often results in the lowering of water table. Okay, water table is nothing but the area which holds the groundwater is the water table. It is more or less a reservoir of water, you can say. Second, the loss of vegetation causes drought and reduction of rainfall and lowering of the water table. Third, irrigation utilizes more than 90% of the total fresh water. Fourth, the increase in population results in water scarcity. Fifth, our water resources like the underground water, rivers, lakes, etc., are polluted and their water can hardly be used without adequate treatment. So, these all are the reasons why we need to conserve water. Now, the question is how can you conserve it? That is, which all are the conservation practices? Due to declining, that is decreasing availability of fresh water and increasing demand, we need to conserve water and manage our water resources. We need to take quick steps to make proper policies and laws and adopt effective measures for the conservation. This can be done by rainwater harvesting, adopting water saving technologies, encouraging watershed development, water recycling, and preventing the pollution of water. Now, let us understand about the rainwater harvesting. The rainwater harvesting is collecting and storing the rainwater, which includes activities aimed at first, harvesting the surface and the groundwater, second, prevention of losses through evaporation and seepage, third, all other hydrological studies and engineering interventions aimed at conservation and efficient utilization of the limited water endowment of an area such as a watershed. Rain is the primary source of water according to the hydrological cycle. Rivers, lakes, and groundwater are all secondary resources of water. We depend entirely on such secondary sources of water and most of the time forget the value of the rainwater. Water harvesting means understanding the value of rain and making optimum use of rainwater at the place. Now, What is meant by watershed management? Watershed management refers to the efficient management and conservation of both the surface and groundwater resources. It includes prevention of runoff as well as storage and recharge of groundwater by various methods like percolation pits, recharge wells, bore wells, dug wells, etc. The central government has started a watershed development project called as the Haryali. It aims at enabling the rural people to conserve water for irrigation, drinking, fisheries, and afforestation. So, water harvesting means understanding the value of rain and making optimum use of rainwater at the place where it falls. Water harvesting is the activity of direct collection of rainwater that can be stored for direct use or can be used to recharge groundwater. Water has been harvested in India from ancient times. Our ancestors had perfected the art of water management. Many water harvesting structures and water conserving mechanisms were followed in each region of the country. People harvested rainwater by collecting water from the rooftops and storing it in tanks built in their courtyards. From open community lands, they collected the rainwater and stored it in artificial wells. They harvested rainwater runoff by capturing water from swollen streams during the monsoon season and storing it in the water bodies. They harvested water from flooded rivers. The storing mechanisms or the water receptacle was known by different names in different areas. They were called as Khatri or Pool in western Himalayas, Beolas or Diggis in the Gangetic Plains, Johads in central India, Bandaras or Keri in the Deccan Plateau, Surangam in the Western Ghats, Korambu in the Eastern Ghats, and Zing in Ladakh. Now, coming to the next point, that is need of water harvesting. In India, we have acute shortage of water during the year. This is because we have not cared to conserve water or rationalized its use. The annual rainfall in India is 1170 millimeters, that is 46 inches. This is higher compared to the world average of 800 millimeters, that is 32 inches. Ironically, even Cherrapunji, which receives about 11,000 millimeters of rainfall annually, suffers from acute shortage of drinking water. This is because rainfall in India occurs in short spells of high intensity. Because of such intensities and short duration of heavy rain, most of the rain falling on the surface tends to flow away rapidly, leaving very little for the recharge of groundwater. This makes most parts of India experience lack of water even for domestic uses. Please remember, rainwater can be stored for ready use in containers above the ground or below the ground. Second point, recharged rainwater can also be recharged into the soil for withdrawal so that later the groundwater recharging can be done and the water can be withdrawn. Okay, now we talk about the water harvesting mechanisms. The elements of water harvesting are given below. First is the catchments. You might have heard of this word catchments. The catchment of a water harvesting is the surface which receives rainfall directly. It can be a paved area like a terrace or courtyard of a building or an unpaved area like a lawn or open ground. Temporary structures like sloping sheds can also act as catchments. Second, conduits. Conduits are the pipelines or drains that carry rainwater from the catchment or the rooftop to the harvesting system. Conduits may be of any material like polyvinyl chloride, that is PVC, asbestos, or galvanized iron, that is GI, or materials that are commonly available. Point number three, storage facility. Rainwater can be stored in any commonly used storage containers like RCC, masonry और प्लास्टिक वाटर टैंक्स. आपने तो सिंटेक्स विंटेक्स सुना ही रहेगा, वो तो प्लास्टिक वाटर टैंक हो गया. So rainwater can be stored even there. Point number four, recharge facility. Alternative to storing rainwater can be used to recharge the groundwater aquifers. This can be done through any suitable structures like the dug wells, bore wells, recharge trenches, and the recharge pits. Now, coming to the next point, storing water for direct use. Please just don't keep listening, but also definitely remember which points are likely to be asked in MCQs as an option. So storing water for direct use. An underground RCC, that is reinforced cement concrete, or masonry tank can be used for storage of the rainwater. The tank can be installed inside the basement of a building or outside the building. I can ask you, where can we build the tank? Is it inside the building or outside the building? What is the material to be used for storing this tank? Is it RCC or masonry ground? Something like syntax. Okay. Each tank must have an overflow system for situations when excess water enters the tank. So जब extra पानी बाहर आ जाएगा, the people will know that the water is about to be wasted. So people can take care of that and the water wastage can be prevented. So we have an overflow system in such tanks which are certainly useful. So each tank must have an overflow system for situation when excess water enters the tank. The overflow can be connected to the drainage system. Generally, runoff from only paved surfaces is used for storing since it is relatively free of bacteriological contamination. Contamination is nothing but the entry of microorganisms. Drain pipes that collect water from the catchment area, that is the rooftop, are diverted to the storage container. To prevent leaves and debris from entering the system, mesh filters should be provided at the mouth of the drain pipe. Further, a first flush device should be provided in the conduit before it connects to the storage container. Very, very important. Why is it needed? Which device has to be provided in the conduit? Can be a question asked. If the stored water is to be used for drinking purposes, a sand filter should also be provided. Water quality improves over time during storage in the tank because impurities settle down in the tank if the water is not disturbed. Even pathogenic is nothing but disease causing, that is, harmful organisms gradually die out due to storage. Biological contamination can be further removed by disinfecting the water. Many simple methods of disinfection are available which can be carried out at the domestic level. Now let us understand about recharging the groundwater aquifers. Various kinds of recharge structures are possible which can ensure that rainwater percolates and it goes down in the ground instead of draining away from the surface. Some of these are: first, bore wells and dug wells. These are used to raise the underground water table by collecting the rainwater on the rooftop of the building, which is then diverted by drain pipes to a filtration tank. From there, it flows into the bore well or dug well. Second is the recharge pit, excavated into the ground, lined with a brick or stone wall with openings at regular intervals. Third, percolation pits, that is soak away, is a bored hole of up to 30 centimeters diameter drilled in the ground to a depth of 3 to 10 meters. I can ask you the diameter. I can ask you how deep is it made, that is percolation pits, how deep they can be. Fourth one, recharge trenches. These are excavated on the ground and refilled with porous media like pebbles, boulder, or brickbats to harvest the surface runoff. Fifth, permeable surfaces like a patch of grass is used to retain a large proportion of the rainwater falling on it, yielding only 10 to 15% as runoff. This can be asked to you, okay, how much is the percentage of the yield with the use of permeable surfaces like a patch of grass. Now, yeah, Dashing Gamers is asking me the paragraph. Well, this is page number 131. Okay, the left hand side of the book, the last paragraph, that is irrigation. Okay, I'm reading out irrigation now. So, irrigation. Irrigation refers to the process of watering of agricultural plants through artificial means from wells, tanks, tube wells, canals, etc. From the point of view of sustained agricultural production and all round development, water is the most precious resource. Presently, about 92% of water is used for agriculture, 2% for industries, and 6% for drinking and domestic purposes. A very, very important point. I can ask you, which is the activity that uses maximum of the water? So it is agriculture, because that accounts to almost 92%. It is only 2% that is used by the industries and 6% for drinking and domestic purposes. I can even ask you this question in the form of match the following is column 1 and column 2. So keep these figures in mind. For farmers, rainfall is still the most important source of water. About 55% of the net sown area in the country depends on rainfall to sustain crop production. It is more than half. Remember this. So it's about 55% of the net sown area in the country that depends on the rainfall to sustain crop production. Success in dry farming depends on moisture conservation practices and judicious use of available water for irrigation. Under this situation, it is imperative to utilize artificial means to raise crops. In India, irrigation has been practiced from ancient times. A number of artificial lakes and canals that dot the country are centuries old, and some of them have served for more than 1,000 years. The notable examples are the two big tanks in Chingalput district of Tamil Nadu, constructed in 8th and 9th centuries AD, and the Grand Anicut built across the Kaveri River during the 2nd century AD. Very, very important points to remember, friends. The irrigation canals built by various rulers from time to time testify the importance of irrigation in the development of agriculture in India. After India attained independence and began planned development, the increase in irrigation potential was regarded as one of the prerequisites. Prerequisites are nothing but requirement for agricultural development in the country. This was because of the following reasons. So, the first reason is the uncertainty of the rainfall. The rainfall in India is highly irregular in place and time, that is, normal rainfall is marked by wide fluctuations in different parts of the country. That is, there is no consistency. Sometimes the monsoon arrives early and at times it comes late. Not only is the arrival and withdrawal of rainfall uncertain, but also its continuity, rhythm, and intensity uncertain. The rainfall is not regular throughout the rainy season, leading to water scarcity and withering of the crops. Hence, irrigation is the only means to supplement the rainwater to raise the crops. The second point is uneven distribution of rainfall. In India, the distribution of rainfall is quite uneven. Most parts of the country receive 80% of the annual rainfall from June to September from the southwest monsoon. Very, very, very important point. Most parts of the country receive 80% of the annual rainfall from June to September from the southwest monsoon. Very important point, friends. Western Ghats and Eastern India receive more than 250 centimeters of annual rainfall, whereas the northern plains and the eastern peninsula receive between 100 and 200 centimeters of rainfall. Saurashtra, Kutch region of Gujarat, parts of Punjab and Haryana, and western half of Rajasthan lie in the arid zones. Arid is nothing but dry. Here, the amount of rainfall is low and there's a constant scarcity of water. This inadequacy of rainfall has to be met by irrigation. We come to the next point, that is crop requirements. Different crops require different quantities of water for their growth. First, most of the crops do not require water when they're maturing. Please remember, crops do not require water throughout their entire all phases of the life, but they require more water while they're developing, but do not require water when they're maturing. However, grain crops require more water during the time earheads are formed. India has three cropping seasons: the Kharif, the Rabi, and the Zaid. The Kharif crops, which occupy the largest area in the country, are dependent on the monsoon rains. Please remember this. The Kharif crops occupy the largest area in the country and are dependent on the monsoon rains. Where irrigation facilities are not developed, these crops are grown as rain-fed crops. Rabi crops are grown on the soil moisture which is left after the harvest of Kharif crops or over the area where a short supply of irrigation is available. Zaid or summer crops are exclusively irrigated crops. Very, very important. I can ask you this. Dash are exclusively irrigated crops. And options I can give is Kharif, Rabi, Zaid, summer crops, both C and D. So your answer should be both C and D, that is Zaid or summer crops. Further, the rapidly growing population has forced the farmers to raise two or three successive crops in a single year. This cannot be done without the help of irrigation. High yielding varieties requiring higher quantity of chemical fertilizers need more moisture, which could be supplied only through irrigation. Commercial crops like sugarcane need higher quantity of water as they require frequent watering, which could be managed through efficient irrigation system. Now coming to the next, that is nature of the soil. The water requirement of different crops depends on the nature of the soil. For example, clay soils have higher moisture holding capacity and therefore require less irrigation. On the other hand, the sandy loam have less moisture retentive capacity and need frequent watering. Similarly, the level and the lowland areas require less water than the sloping and the highland areas. Keep this in mind as well. Now, coming to the next point, number 5, to utilize river water efficiently. Many rivers in India are not perennial and carry insignificant flows during the Rabi season. There is also a wide disparity in the water flow from year to year. The rivers of central and southern India have water for the 4 months of monsoon rains and remain largely dry during the 8 months of the year. Therefore, to effectively utilize the water of these rivers, means of irrigation have to be used. Point number 6, to maximize production. To obtain maximum production, irrigation is a must. According to agricultural scientists, the production of irrigated crops is more than the unirrigated crops in the same area. Coming to the next point, means of irrigation. Based on the availability of surface, that is river and groundwater, relief, soils and climatic conditions, different means of irrigation are utilized in India. The conventional means of irrigation include wells, tanks and inundation canals. The modern means of irrigation include tube wells, perennial canals, drip irrigation, etc. For example, in the crystalline soil areas of Deccan Plateau, tanks form the major source of irrigation, a very important point, whereas the alluvial tracts of the Gangetic and coastal plains are best suited for canals and well irrigation. The conventional means of irrigation used in India are the following. A, that is the first one, wells. A well is a small hole dug in the surface of the earth to obtain water from the subsoil for irrigation and other purposes. It is a cheap, simple, and dependable source of irrigation. Well irrigation is practiced in areas where plenty of groundwater is available and the depth of the water table does not exceed 15 meters. Keep this in mind. Coming to the next area. Well irrigation is confined yani limited, mainly to the alluvial plains, where owing to the soft nature of the soil, wells can be easily dug and the yield of the crops from the land after irrigation is considerably high. Wells are dug in the middle of the area to be irrigated and at a place which is relatively at a high level. The areas where well irrigation is practiced include Uttar Pradesh, Goa, Punjab, Haryana, Bihar, Rajasthan, Gujarat, Maharashtra, Madhya Pradesh, Andhra Pradesh, Karnataka, and Tamil Nadu. The water from the wells is lifted for irrigation in a number of ways. First, the Persian wheel method. It is used mainly in Punjab, Haryana, and western Rajasthan. It is a partly submerged vertical wheel which with buckets attached to the rim. As the wheel is turned by draught animals rotating a geared horizontal wheel, the buckets are filled and emptied into a trough above, which carries the water to the crop sown fields. The second one is the lever method. It is used in Bihar and Andhra Pradesh. It is very economical and efficient method of lifting water from shallow wells to a height of 3.5 to 4.5 meters. Remember, this is very economical. I can ask you which is the economical and efficient method of lifting water? And the answer to this is lever method. The lift consists of a strong log laid across a fulcrum, a bucket attached to the long arm by means of a bamboo or a rope, and a heavy weight attached to the other side of the log. When the bucket is full, one person gently releases the rope and the bucket comes up as the stone goes down. The bucket is emptied into the field channel and again lowered into the well. Third point, inclined plane method. This method is also known as moat. In this type, a pair of bullocks move down from the slope inclined plane. Slope is nothing but the inclined plane, especially constructed from the wall of the well, a bucket or a leather bag which is discharged into the connecting channel, pulling from behind. The rope goes through pulley in this process. After discharging the water, the bullocks walk up the slope until they reach the top, by which time the bucket reaches the surface of the water and gets filled. The process is repeated again and again to irrigate the fields. Coming to the next, advantages of well irrigation. First, wells can be dug at a very low cost, which is well within the means of poor farmers. Remember this. Second, oxen, which are kept for plowing the land, can be utilized for drawing water from the wells at no extra cost to the farmers. Third, by the use of pumps and tube wells, water can be lifted even from great depths. Coming to the next, disadvantages of well irrigation. First, wells depend on underground water resources whose distribution varies from region to region. Second, it is difficult to dig wells or bore tube wells in the hilly regions of the north and stony areas of the peninsula. Third, the traditional wells dry up due to the over withdrawal of the groundwater and lowering of the water table. Fourth, availability of electricity and diesel to operate tube wells causes many problems and is costly for the farmers. Coming to the next, that is tube well. It is a deeper well at a depth of 20 to 30 meters from which water is lifted up with the help of power-driven pumps to be used by man. It is also known as lift method. The ideal conditions for the drilling of tube wells are availability of plentiful water at great depths, level land and soft soil for the tube wells to be set up. Third, large fertile area in its surrounding area to be irrigated. And fourth, availability of regular cheap electricity to run the tube wells. The main area where tube wells are used include the northern plains in the states of Punjab, Haryana, Uttar Pradesh, Bihar, West Bengal, Rajasthan, Madhya Pradesh and Gujarat. Coming to the next, that is advantages of tube well irrigation. First, it is an independent source of irrigation. Second, it brings up clean water. Third, it can irrigate large area of agricultural land. Fourth, it is easier to bring up large amount of water in a short time period. Fifth, it is a perennial means of irrigation as it is drilled up to permanent water table. Now coming to the next one, disadvantages of tube well irrigation. First, excessive use of tube well water can lead to depletion of groundwater. Second, it is useless if the water is brackish. Third, it is expensive as it requires continuous supply of electricity. Coming to the next, that is canals. India has one of the world's largest canal systems stretching over more than 1 lakh kilometers. The irrigation canals are of two types. First, the inundation canals. These canals are taken out directly from the rivers without constructing any barrage or dam. Such canals use the excess water of the rivers at the time of floods and remain operational during rainy season. As the beds of these canals are at a level higher than those of the rivers, they get supply of water only when the rivers are in flood. Therefore, these canals have limited use. Coming to the second, perennial canals. These canals are taken out from the perennial rivers by constructing barrages or dams to regulate the flow of water. They can draw water throughout the year and irrigate large areas. Most of the canals in India belong to this category. Now, coming to the important canals in India, in Punjab state, the important canals are the Sarhind Canal, the Bhakra Canal, and the Upper Bari Doab Canal. In Uttar Pradesh, the important canals are the Sharda Canal, the Upper Ganga Canal, and the Lower Ganga Canal. In Haryana, the important canals are Western Yamuna Canal, the Gurgaon Canal, and the Bhakra Canal. In Maharashtra, the important canals are the Tapi Canal, the Pravara Canal, and the Varna Canal. In Rajasthan, Indira Gandhi Canal and the Bikaner Canal. In Tamil Nadu, the Mettur Canal, Aliyar Canal, Lower Bhavani Project Canal. It's Bhavani, I suppose. In Bihar, Sun Canal, Kosi Canal, and Gandak Canal. In Karnataka, Vishweshwarya Canal and the Malprabha Project Canal. Canal irrigation is in practice in Uttar Pradesh, Madhya Pradesh, Andhra Pradesh, Rajasthan, Haryana, Jammu and Kashmir, Assam, and Tripura. Canals also supply water to a sizable part of the irrigated area in Bihar, Odisha, Karnataka, Tamil Nadu, and West Bengal. Mizoram, the least irrigated state, is solely dependent on canals. Very, very, very important point. The northern plains have elaborate system of canals. Important canals in Punjab, Haryana are Upper Bari Doab, Bist Doab, Sarhind, Bhakra, and Western Yamuna canals. The Indira Gandhi Canal, the Bikaner Canal, and canals of the Chambal projects are major canals in Rajasthan. Canals in Uttar Pradesh include the Eastern Yamuna Canal, the Sharda Canal, Ramganga Canal, and the Betwa Canal. Damodar Canal and Mayurakhi are important canals in West Bengal. In Bihar, canals of Sun, Gandak, and Kosi projects are the most important canal projects. Please remember, I can ask you a match the following on this particular data given. In South, the canals of the Nizam Sagar, Nagarjun Sagar, the Tungabhadra projects, and of the Krishna and Godavari deltas are the major ones. In Tamil Nadu, nearly one-third of net irrigated area is under canal irrigation. Advantages of canal irrigation. First, the rainfall deficiency in some areas is made up by canals taken out from the perennial rivers. In arid areas like Rajasthan, canals have proved to be boon, as a result of which sandy patches are yielding good agricultural harvests. Third, canal irrigation has enabled Punjab and Haryana to be called the granary of the country and nucleus of the Green Revolution. Very, very important point. Major parts of Tamil Nadu enjoy rainfall during winter season while summer remains dry. Thus, irrigation is needed in summer to make up the lack of rainfall. Canal irrigation provides a solution to this problem. Now, coming to the next, that is disadvantages of canal irrigation. At some places where the perennial unlined canals flow at the ground level and between raised high banks, the water table may reach the surface and make the once cultivable soil completely waterlogged. Complete saturation of the soil with water may give rise to swamps. Second, in the canal irrigation, the water table is a few feet below the ground. The alkaline salts come to the surface, mix with the soil, and make it unproductive. Third, due to waterlogging, the capacity of soil to absorb water decreases. So, a few centimeters of rainfall in excess of the normal covers the land with a sheet of rainwater, which, in the absence of proper drainage, ruins the standing crops, houses, and even stored food grains and fodder. Coming to the next, that is tanks. Tank refers to a small bund of earth or stones built across a stream to impound water, which is then led through narrow channels to the cultivated fields. Tank irrigation is in practice in peninsular India, including Maharashtra and Gujarat. Tanks constitute a special feature of irrigation in the Deccan because of the following reasons. First, the rivers of the Deccan are not snow fed and are mainly dependent on the rain water. Second, there are many streams which become torrential during the rainy season but dry up when the rain ceases. Third, the hard rocks in the area do not suck up water, so wells also cannot be made there. But the tanks can be easily made by means of making dams in hollow spaces in which rainwater is stored in large quantities for distributing regular supply of water through the channels to the arable lands in the dry seasons. Fourth, the terrain of the Deccan Plateau is very uneven with many natural depressions where tanks can be easily built. Tank irrigation has reached its highest perfection in the south, especially in Andhra Pradesh, Telangana, and Tamil Nadu. In Tamil Nadu, it is significant in the districts of Tingleput, North Arcot, and South Arcot, in Nellore in Andhra Pradesh, and in Warangal in Telangana. States of West Bengal and Rajasthan too have some irrigation tanks, particularly in their southern and southeastern regions, respectively. Some irrigation tanks do exist in Bundelkhand area in Uttar Pradesh and South Bihar. Now, coming to the next, that is advantages of tank irrigation. In the uneven rocky plateau of peninsular India, where rainfall is highly seasonal, tank irrigation is useful. Second, in the large stretches of the Indian plateau, due to hardy rocky terrain, wells and canals are difficult to construct, so only tank irrigation is feasible. Third, tank irrigation is highly significant in storing the abundant rainwater that would otherwise flow out and go waste. Coming to the disadvantages of tank irrigation. First, tanks get silted up soon and regular desilting is required to make them suitable for irrigation. Second, when the monsoons fail, these tanks go dry and therefore are not dependable source of irrigation. Third, most of the tanks are non-perennial and become dry during the winter and summer seasons when water is urgently required for rabi and the Z crops. Fourth, due to large area coverage and its shallow depth, huge quantity of stored water either evaporates or sinks underground without being used in the irrigation. Fourth, tanks occupy a large fertile area which otherwise could have been utilized for growing crops. Sixth, the lifting of water from the tanks and bringing it to the fields is a strenuous and costly task. But even then, tanks are effective means of collecting rainwater, and their use should be popularized for irrigation, aquaculture, drinking water, and water sports. Now, coming to the drawbacks of conventional methods of irrigation. The conventional irrigation systems suffer from a number of constraints leading to improper utilization of water. These are the following. First, in the conventional system of irrigation, a large quantity of water is not properly utilized. Second, crops are usually subjected to cyclic changes of flooding and water stress situations by providing heavy irrigation at one time and leaving the fields to dry up for about 10 to 15 days. The moisture availability to the crops therefore keeps on changing. This results in poor yields in the crops. Third, the fields situated in low areas always get excess water, causing prolonged waterlogging. Thus, crops are subjected to waterlogging, resulting in poor yields. Fourth, in the fields, about 10 to 15% of land is utilized for preparing channels and distributions, etc., which decrease effective area of cultivation. Fifth, extensive areas of land in the arid and semi-arid regions of India are no longer used for cultivation due to accumulation of salts. Excessive irrigation and poor water management are the main reasons of waterlogging and gradual buildup of excessive salts. Progressive buildup of soil salinity has made the soils unsuitable for cultivation. Coming to the next, that is modern irrigation methods. All these constraints have led to the utilization of modern irrigation methods which are highly scientific. Some of the important ones are discussed. First, furrow irrigation. It is a type of flood irrigation in which the water poured on the field is directed to flow through narrow channels dug between the rows of crops instead of evenly distributing the water throughout the whole field. The furrows must have equal dimensions in order to guarantee that the water is distributed evenly. Furrow irrigation is useful in the areas where water is easily available. Second, spray irrigation. In spray irrigation systems, a long hose is set to a water source on one side, and on the other side, the water is released through spray guns to the field. The spray irrigation is expensive as it requires complete complex machinery but utilizes water more efficiently, reducing the amount of water needed to irrigate a field. However, water is lost through evaporation in spray irrigation, and plant diseases that are caused due to excess moisture can occur due to overwatering. Coming to the next, drip irrigation. It is the most advanced and efficient method of irrigation. Please remember this. Usually used to irrigate fruits and vegetables, this system consists of perforated pipes that are placed between the rows of crops or buried along their root lines and give water directly onto the crops. As a result, evaporation is drastically reduced and irrigation water is conserved. Drip irrigation allows the grower to customize an irrigation program most beneficial to each crop. Coming to the next, that is sprinkler irrigation. In this method of irrigation, a pipe fitted with a nozzle on the top is used through which water is sprayed directly to the required plants. It is often referred to as overhead irrigation method. Now, advantages of sprinkler irrigation. First, there is no loss of water by seepage. Second, there is no loss of water by evaporation. Coming to the disadvantages of sprinkler irrigation. First, it is an expensive method of irrigation. Second, it is helpful for a small land area. Third, it is used for crops which require less water. Coming to the interlinking of Godavari and Krishna rivers. The Andhra Pradesh government created history on September 15, 2015 by linking the rivers Godavari and Krishna in order to make the Rayalaseema district drought proof and to help the Delta region which suffers due to water shortage. On September 1, water from Godavari was released into the newly constructed Polavaram Canal. After flowing for 174 kilometers, it reached the river Krishna at Prakasam Barrage in Vijayawada in the village of Palerlamudi on September 15. Of the 80 TMC of Godavari water, 10 TMC will be diverted to domestic and industrial users in major towns in Krishna and West Godavari districts. 70 TMC will be used for irrigation. This water will be enough to irrigate 7 lakh acres of paddy fields. Thus, the Krishna water can be saved and stored at Srisailam Dam, from where it can be supplied to the drought-prone Rayalaseema region. So, friends, I've completed reading the chapter Water Resources from 10th Standard ICSE Geography as was being demanded by one of the viewers. This is the total geography by Morning Star. Okay, Suryansh Singh. Love you too, bacha. So we have completed this. If you are new to the channel, kindly subscribe. Spread a word about this channel to all of your friends because we will be definitely working for ICSE 10 standard till your second semester final board exams also get over. If you are new to the channel, kindly subscribe and hit the like button if you have genuinely liked the efforts that we are trying to put in. Do comment, give your suggestions, and ask your friends to join so that we'll solve many more papers. Tomorrow we will catch up with each other as early as possible, okay, to solve many more papers. Right now, bacho ab so ja. Love you all. God bless you all. And here I end up the stream. Please do not forget to hit the like button and also the bell icon so that tomorrow, as soon as we come live, you will get to know. On your way to the school, also, you can hear the chapters. You can revise on the way, and we will be there with you till the last moment. Thank you so much. Now, sleep well and keep on recollecting whatever points we have talked about. Thank you so much. Bye bye. Good night.